Hello everyone. Let's get on with the proofs. This time, the limit formula for trigonometric functions. We have to talk about these two. This one is harder and more important. This one not as important and not as hard. Naturally, we're going to do the second one first. But we have to assume the first one, so let's do that. Assume this is true. We'll postpone this proof, but assume that, and then let's go ahead with the second. The proof is pretty simple, like this. Some algebraic manipulation. To this quantity, we multiply a strategic quantity, this one, cosine of theta plus 1, to both numerator and denominator. Why did I select that? Because we have cosine of theta minus 1 there. So this is a minus b form. So if you multiply a minus b times a plus b, what do you get? A squared minus b squared. That's what we have over here. Cosine squared minus 1, that's negative sine squared because of the Pythagorean identity. Now that I have sine, I can decompose 1 of the sine of theta like this, and this will become 1. And how about the rest? That's easy. Trivial limit. Just plug in the value. In the end, this is 1, and then this limit is nothing more than 0 over 1 plus 1. In the end, we have to have 0. Simple deal. How about the first? Now this is harder, and we are going to use a kind of sandwich rule, and that depends heavily upon geometry. Let's begin. Let's consider this picture, a big triangle and a sector and smaller triangle. Because of all these inclusion, clearly the area of the inside and an area of the medium and an area of outside will have this kind of relation. Now, what are those areas? It'll turn out that area of the inside is 1/2 sine of theta, area of the sector is 1/2 theta, and area of the outside is 1/2 tangent of theta. Why? Well, if that is not really immediate to you, well, here you go. Area of the sector is 1/2 radius squared theta, 1/2 r squared theta, and that happens to be 1/2 theta because radius is 1. And how about the inside? 1/2 and then the base times height. But the height, this comes from sine function because this is hypotenuse, and then we are looking for opposite of theta. So we have sine of theta there, and eventually boils down to 1/2 sine of theta. How about big triangle? Base is OA, so that's 1, and then this height is tangent. You see, from A to D, we don't know that. We do not know hypothesis, so this should be tangent. So AD is tangent, and then we have radii, radius is 1, so we have 1/2 tangent of theta. Okay, let's go back to where we were. 1/2 sine of theta, 1/2 theta, 1/2 tangent of theta. So after simplification, this is what we get. Divide everything by 1/2 sine of theta, and we get theta over sine of theta is, after simplification, 1 of cosine of theta. And flip it over, we have cosine of theta and sine of theta over theta, 1. We have this relation. By the way, all this is true because we have positive theta value, and all these quantities are positive. If you have negative numbers flying around, then we have to be a little bit careful because whenever you have to multiply or divide a negative number, then the direction of the inequality will change. But in the end, you have to get the same result even if the angle theta is negative and the picture goes down to the fourth quadrant. I didn't do it, but you can do it on your own if you want to. It'll turn out okay. Alright, now that we have this inequality, we can take the limit. Limit of cosine, that's 1, and limit of this constant, that's 1. So left hand side and right hand side are both converging to the same value, so the middle quantity will have to converge to the same value as well. And that's how you can prove the middle quantity converges into 1. When theta is going to 0 in negative, in that case the picture will have to go to fourth quadrant, and then you can use similar kind of logic. You have to be a little bit careful because some negative numbers are flying around, but in the end this inequality will remain the same. Okay, there goes the proof of the limit theorem. Okay, enough time for derivatives. Okay, alright. Derivatives of sine and cosine. Wait a minute. Do we have the proof here? No, we don't. So we'll do that in a separate video.